Now in this lecture we shall be discussing about the section 4 of AS1170, and that basically deals with the site exposure multipliers. So as per the surroundings, or we can say as per the various research that has been done. So as a simple introduction, what we can see here is that the behavior of the wind when we're talking about this particular terrain category. Here you can see that it is a simple plain ground, and as compared to this area where there are n number of buildings nearby, the wind speed shall not be same in both the we can say topographies. So it shall be different. So that is the basic context that in section 4 basically that deals with the site exposure multipliers. So the to start with that, basically if we are dealing with this section 4.2, so section 4.2 deals with the we can say terrain and height multiplier. So basically we're talking about two parameters. First is the terrain and second is the height. So as per the terrain and height, we have to multiply the wind speed. Which wind speed right now we are talking about? We are talking about the V SIT beta and also and V design theta also. So basically when we find out the value of the VR, we have to multiply it with MC and MD. And in here we were talking about the MZ category and MS and MT. So basically, this is the equation for VSIT beta. So V are the regional wind speed that we already discussed in the early lecture. MC is the climate change multiplier that also we have discussed. MD is the wind directional multiplier that also we have discussed. Now we are discussing about the MZ category. So let me just highlight what we have already discussed. We have understood about the VR, we have understood about the MC also, we have understood about the MD also. Now we shall be targeting that we to understand basically MZ category. Now this MZ category, that is basically we can say the terrain and height multiplier. So we can say that as a basic concept here, the terrain over which the approach wind flows towards the structure, that can be assessed first of all towards the category itself. So this is it as per the code. This is terrain category 1. So what exactly is the we can say meaning of terrain category 1? So that classifies open terrain with we can say very few or no obstruction. So in here we can see that there are no as such obstruction to the flow of the wind. There are we can say clearly nothing we can say for the obstruction. So in that particular case we classify it as terrain category 1. So example for that are we can say flat, treeless, poorly grassed plains, open oceans, rivers, canals, bay and lakes. So when there are no obstruction, we can classify it as terrain category 1. After that, when we are talking about the terrain category 2. So terrain category 2, we can say that these are open terrains, including grassland like we have shown here, with well scattered obstructions. So in here we can say that obstructions are there, like there is this one tree here and one tree here. So we can say that in this particular case there are these well scattered obstructions, and having height generally between 1.5 meter to 5 meter. So we can say that let us say if we're talking about this tree as an obstruction, the height may be in the range of 1.5 meter to 5 meter with no more than 2 obstructions per hectare. So example are farmland and cleared subdivision with isolated trees and uncut grass. So after that, if we are talking about the terrain category 2.5. So terrain category 2.5, in this particular case, we can say that these are the terrain with some trees or isolated obstructions. And we can say that in outer urban areas. So in Australia, I can say that there are many outer urban areas and with scattered houses, or we can say large acreage development with more than 2 and less than 10 buildings per hectare. So in this particular case, we were saying that it has to be less than 2 buildings per hectare for terrain category 2. But when we're talking about terrain category 2.5, we can say that number of the large developments or substantial building structures that can be between 2 and 10. So in here, we can say that scattered obstruction that can be between 2 and 10 buildings per hectare. between 2 buildings per hectare to 10 buildings per hectare, we can classify that as terrain category 2.5. After that, when we're talking about a terrain category 3, this is a category having numerous closely spaced obstructions having height generally between 3 meter. If we say about obstruction as OBAST, just as a short form, so between, we can say the height having 3 meter to 10 meter, and it has to be like at least there are these 10 house size obstruction per hectare. So we can say that, let us say this is the hectare, so we are having, in the range of 10 houses, 10 house size obstructions per hectare. So example for these are, we can say suburban housing and light industrial estate or dense forest. After that, when we're talking about a terrain category 4, so terrain category 4, we can say is that they are, first of all, we can say very limited to use. So when we are talking about Australian cities, it is not like they are very much densely packed, they are scattered. So as a conservative approach, what I usually advise is that it is always better to go ahead with terrain category 3, and terrain category 4 has to be used very carefully, because we can say that it drastically reduces the wind speed also, or final wind pressure. So it is always better to take a little bit of conservative approach and try to prefer terrain category 3 instead of terrain category 4. So the simple thumb rule here is that for terrain category 4, as per the code, that 10 meter to 30 meter building height, the building height has to be, or the surrounding building height, but it has to be between 10 meter to 30 meters, and it has to be closely spaced obstruction with large city centers and well developed industrial complexes. So we can say that selection of terrain category shall be made as per the decision of the engineer, and according to the guidelines that has been given in section 4.2 of AS1170, AS1170 part 2 2021, we can accordingly find out the terrain category, and on the basis of that we can find out the value of the MZ category also. So TerrainHeight multiplier, if you want to account that in a simple word, that is a factor that accounts for the variation of wind speed with height and terrain roughness. So terrain roughness, if you say that if it is a plain ground, obviously the terrain is smooth, and if there are these buildings, let us say these are the various buildings that are being encountered by the wind, and if the the wind is flowing, like it has encountered the obstructions, so that obstruction shall not be encountered if it is a complete plane, because wind shall easily be passing across the because there are no as such obstructions. So that is why it is a factor that account for variation of wind speed with height and terrain roughness. So in addition to the terrain roughness, we are classifying it as a function of height also. So it is defined in section 4.2, and to determine the TerrainHeight multiplier, you need to classify the terrain category of a site based on the surface roughness and obstructions, and then use this table, that is table 4.1, to find out the corresponding value of MZ category for your site height and wind region. So let us say in this particular case, so supposing the terrain category is 3 in your case, so considering terrain category 3, we can see here that MZ category is less than 1 also. So for a building of 10 meter height, let us say, we can say that MZ category is 0.83. So ultimately we are reducing the site wind speed by as high as 17% reduction. It means that we are only taking 0.83 times the coefficient. So we can classify all the remaining functions as x. Let us suppose that is an arbitrary value. So if we're talking about the MZ category itself, so if our terrain category is 3, so in that case we are simply reducing the site wind speed by 17%, that is by taking the coefficient as 0.83. At the same time, if that particular terrain category is 2 instead of 3, in that particular case, 0.83 gets replaced with 1.0. So in here you can see that this is the value 1.0. And at the same time, we can say that if we are talking about, let us say, very tall buildings, so in those tall buildings, if we are talking about a terrain category 3, for let us say height of 50 meters. For terrain category 3, we are getting 7% increase in the site wind speed, and same time we're talking about terrain category 2, we're getting as high as 18% increase in the site wind speed. So that is a basic rule here. As the terrain category goes higher, your effective pressure goes lower. As your height increases, your height multiplier increases. So there is a like a both of the we can say increase and reduction and is opposite to each other. Yeah, that is if our terrain category increases, the coefficient decreases. But if our height increases, obviously the coefficient also increases. So according to that, we can decide the TerrainHeight multiplier. So as per my experience, in most of the cases, we shall be dealing with we can say these two terrain categories most of the times. So that is just my experience. So in most of the cases, we are dealing with either terrain category 2.5 or terrain category 3, because terrain category 1 is very rare, and terrain category 4 is also like very rare. So in most of the cases, either it is 2.5 or either it is 3. So that you have to decide when when you are designing the structure. So I hope the concept is now clear to you, that how you can calculate the terrain height multiplier for different terrain obstructions. So in the next lecture, we shall be learning about the shielding multiplier.